hole ever swallow Earth? It's one of the biggest questions people ask about black holes. Today, August 3rd, 2026, a new article from space.com reported something that surprised astronomers. For decades, we've pictured black holes as cosmic vacuum cleaners, objects that swallow everything around them. But this new research suggests that's not the full story. Black holes may actually eject enormous amounts of material back into space. That changes how scientists think black holes grow and evolve. So instead of just reading the headline, I put up the paper published in the monthly notices of the Royal Astronomical Society, then downloaded the public X-ray observations used in the analysis. Let's see what the data actually reveal. And by the end of this video, you'll understand what astronomers discovered, why it matters, and whether a black hole could ever actually swallow Earth. Hello, I'm Dr. Amanda Fetch, aka Dr. Amanda Analytics. And on this channel, Tech AI Space Oh My, we go beyond the headlines to explore the data behind today's biggest space discoveries. So let's dive in. The article on space.com focuses on a black hole in the system called Swift J1727.8-1613, about 8,800 light years away. Now in 2023, this black hole suddenly became one of the brightest X-ray objects in the sky. Now that wasn't because the black hole suddenly appeared. It was because it began pulling material away from a nearby star. Now, as that gas spiraled toward the black hole, it heated up to millions of degrees and produced a massive burst of X-rays. Now, astronomers watched the entire event unfold. But here's something interesting. That discovery didn't happen today. The understanding did. That's how science works. Researchers collected the observations in 2023, spent months analyzing data from multiple telescopes, tested their theories and conclusions, and now published the results. Today's headline is the result of that work. One thing I love about astronomy and space is that much of the data is public. So the observations I analyze come from MAXI Mission, an X-ray telescope mounted on the International Space Station. Now, if you'd like to explore the same data yourself, I've included the direct link to the MAXI archive in the description below. Now, once you navigate to the data, just click One Day LC to download the daily light curve. Now, you'll also find a README file that explains what each column in the data means. Now, that raw file doesn't include descriptive labels, so I used the documentation surrounding. You can also Google and look these things up on your own to identify the observation dates, X-ray energy bands, and measurement uncertainties before analyzing the data. Now, that's a good reminder that understanding your data is the first step in any analysis. Now, let's dig in and see what that data actually reveals. So, the first graph I pulled together using Python shows the black hole's X-ray brightness over time. Now, when we look at this, each blue point is a real observation from the MAXI telescope. Now, the orange line smooths out the daily fluctuation so we can clearly see an overall trend. Now, notice how quickly the brightness rises. That's the beginning of that feeding frenzy described in today's article. Now, the system reaches its peak, then gradually fades over the following months. Now, this graph tells us when the event happened and how energetic it became. But it doesn't tell us everything. So I broke the observations into different X-ray energy bands. Now, think of these as different types of X-rays. Now, instead of looking at only total brightness, astronomers can compare how different energy ranges change over time. Now, notice they don't all evolve in exactly the same way. Now, that tells us the environment around the black hole was changing throughout that outburst. Now, something more complicated than simply matter falling into a black hole was happening. Now, this is where today's paper, or should I say what I'm kind of throwing out there based on this space.com research, and also the paper and the information to pull that up is in the description, so make sure to check that out. Now, the researchers combined X-ray observations like these with measurements from the Very Large Telescope. Now, together, those observations showed that even after the black hole's brightest phase had passed, it continued launching powerful winds that blasted material back into space. Now, let's unpack that. In other words, the black hole wasn't simply swallowing everything. It was also ejecting matter. Now, the researchers estimate that over the course of this event, the amount of material expelled may have been comparable to the amount actually consumed. Now, this is why discoveries like what we're reporting today matters. Now, this challenges one of the simplest ideas people have about have about black holes. They're not just cosmic vacuum cleaners. They're much more dynamic systems than we once thought. So, back to our original question. So could a black hole ever swallow the Earth? Not this one. Again, coming back to the name, kind of a tongue twister, Swift J1727.8-1613 is about 8,800 light years away, and there's no evidence it poses any threat to Earth. But today's discovery we're reporting on reminds us that even some of the most famous objects in the universe still have surprises waiting to be uncovered. One of the coolest parts of this, you don't have to start with the headline, because the observational data is public, and I showed you how to access it, so you can explore this evidence yourself. You don't have to trust my word or other scientists' words for it. Now, I've linked the article, the MAXI archive, and the research paper in the description, as I kind of mentioned before, so if you'd like to dig in deeper, you can do that. Now, I want to hear from you. Were you surprised that black holes may eject as much material as they consume? And what space discovery should we investigate next by downloading and analyzing the data together? Now, if you enjoyed this breakdown, don't forget to like and subscribe. Until next time, keep looking up and keep asking questions. I'm Dr. Amanda Analytics signing off. Thanks for tuning in. Take care.